I'm Anil Kumar, and in this video we'll explore absolute maximum and minimum of a function when one side bound is the condition for us. So one boundary condition is given to us, the other side it is not bounded. The question here is determine absolute maximum or minimum for each of the following. So we have two functions here. This one is a linear function within the domain where x is greater than 0 but less than equal to 5. Then we have a quadratic function here where x is greater than minus 3 and less than equal to 2. You will see in these examples we have greater than, not greater than equal to on the lower bound, and therefore these functions are bound only from the right side. You notice that. So in these functions it is not necessary that you will get both absolute maximum or minimum. If you have restrictions on both sides, then it is a must to have both extreme values, right? So this is kind of important to understand. So you could expect only one of those values. Now let's start answering the questions. So first thing is you have to check whether the function is continuous or not within the given domain. So within 0 to 5 it is straight line. We know it is continuous, right? So that is not an issue. So it is continuous. Let's adopt the algorithm to find absolute value of maximum or minimum. So first step is find the critical points, that is where derivative is 0 or undefined. So derivative for this function is 5 minus x is minus 1. Now minus 1 can never be 0, so we have no critical number, right? So we have no critical number here. Okay, so that means we have to only check the values for f of 0 and f of 5. Now f of 0 I'm checking, but it is not really required. I'll use it to graph. F of 0 is 5 minus 0, 5, but we know f of 0 does not exist. So there is a hole at this point, right? So there is a hole. It is not in the domain for us. Okay, there is a hole here since it is not included. Now let me also check what is f of 5. I checked only to help me sketch a line. Okay, f of 5 will be 5 minus 5, and that is equals to 0. Now with these points we clearly know that we have one extreme value only, not both. Okay, let me sketch it also to show you. So we are working in the domain 0 to 5. That means from here to, let us say this is 5 for us. Okay, now let's sketch the graph of this function. At 0 the value is plus 5, so I'm putting a hole there since this value is not included, and at 5 the value is 0, so this value is included, so I'm making a filled in circle. So that is the graph of f of x. So this is f of x for us. Clearly from the graph you can see we have only one value, which is absolute minimum. We do not have absolute maximum value here, right? So we have absolute minimum. Now that occurs at x equals to 5 and the value is, and f of 5 is equal to 0. So we have absolute maximum here, and you could say absolute maximum is at, so we can say absolute maximum at x equals to 5 and the value is 0. So that is how such questions can be answered. Now that's a point to be noted, that if we have one side bound function, in that case we may not have one of the absolute values, right? Let's do the next one. Follow the same procedure. Parabola is continuous, right? So it is continuous. It is important to check this and then move forward. And let's find critical point, that is f dash x. In this case f dash x is half times 2 times x minus 1 times derivative of inside function, which is 1. Anyway, that gives us x minus 1. So when is it 0? F dash x equals to 0 implies x equals to 1. So we have one critical point, and that is at x equals to 1. So second step is find the values of the function at the critical point. In this case it is 1. So let's substitute 1 here. So we get half of 1 minus 1 whole square, which is 0. We also have to check the values at the two extreme values. This one is not included. We are only checking to help us sketch a graph, okay? F of minus 3 is half of minus 3 minus 1 whole square, which is 4 square is 16. 16 divided by half is 8, right? So remember, this is a whole, right? It is a whole. It is not the point on the graph, okay? And then the other extreme value which is included is 2. So at 2 it is half of 2 minus 1 whole square, which is 1 square is 1, so it is half. Now you compare these values. Also sketch the graph. It's kind of important to sketch the graph also, since you understand how the graph looks like and are we really working with maximum or minimum values or not, right? So we are bound between minus 1 and 2, minus 3 and 2. Let's say this is 1, 2, 3, and then here we have 1, 2. At minus 3, the value of the function is 8. At 1, it is 0. So it is 0 at 1. So let me say, 0 at 1. At minus 3, it is 8. So let's take a value 8 here, okay? But it is a whole, right? So I'm making a whole here. Big and clear. At 2, it is half. So at 1, at 2, it is kind of here, but this value is included. So basically, if you see the graph for this function is, it has a 0 at 1 as expected from the equation. If I write x equals to 0, I get half value, right? So it is kind of a graph which is a parabola like this, right? So this is the parabola we are talking about. Do you see that? Now in this parabola, you can see we do have a minimum, right? So it is one side bound, but we do have a minimum value which is 0, right? So out of these values also, you could have said that this is absolute minimum, right? So this is absolute minimum. However, that value is not maximum. We have values higher than this, but the highest value is not in our domain, and therefore we will write only one answer for this, and that is that it has only absolute minimum. Do you understand now? Minimum. And that absolute minimum occurs at 1 and the values is 0. So 1 and 0. So this is your absolute minimum, right? So that is the one which we are talking about. Okay. So I hope with this example you also understand that we could have absolute maximum minimum questions in the test paper where the function is bound from one side. So these examples are not in your book. So I'd like you to go through them and understand the concept. So these are very simple questions only to make you understand the concept. I hope that helps. Thank you and all the best.